Hello students, today we will solve another problem, that is a load of 8 kilonewton to be raised with help of steel wire. Find the dia of steel wire if stress is not exceeded by 80 Newton per mm square. This problem we can understand by this figure, that is one wire is there, one thin wire is there, and we are putting a load of 8 kilonewton on that wire, and that wire is fixed somewhere. Okay, then what will be the diameter of that wire if the stress is not exceeded by 80 Newton per mm square? For that, to find the dia of wire, first we will write the given data. That load is 8 kilonewton, that is nothing but 8 into 10 raised to 3 Newton. We have to convert kilonewton to Newton. Kilo means 10 raised to 3. Then next they have given, that is stress. Stress is 80 Newton per mm square. And what we want to find? We want to find diameter. Now, as we have solved some problems before, what is the change in length equation? Okay, or else we can take the stress formula. What is stress formula? P by A. Now, P is what? P is load. A is nothing but area and sigma is nothing but stress. Now, if we see, we have P, we have stress, but we don't have A. Now, A is nothing but, here I'll write, A is nothing but pi by 4 d square. Now, from area formula, we can find diameter, that is unknown term. So, first I'll write the values of that, or else we will shift the terms first. Okay, first stress, this is P and this is A. A is nothing but pi by 4 d square. Now, what I'll do? I'll transfer this diameter to this side and stress to the opposite side. So when the diameter will come or will transfer to this side, what will happen? It comes here, and this is P, this is pi by 4, and this is stress. Now I'll substitute the values. What is P? P we have written here, that is 8 into 10 raised to 3, and pi by 4 into, what is stress? 80. Now d square is equals to, after calculating this, we will get 127.32. Now we want to find D, but here we are getting in D square. Here we are getting in D square. So what we have to do? We have to put a square root on this value, like this. Now after putting the square root, what we will get? We will get the value of diameter, that is 11.28. So the unit of this is mm. So 11.28 is the diameter of this wire to put a load of 8 kilonewton. Okay, now we will see the next problem, that is a hollow steel tube has internal diameter 200 mm. What should be the minimum external diameter so that it may carry a load of 1.5 into 10 raised to 6 Newton without exceeding a stress of 100 Newton per mm square. So to understand this problem, there is a tube like this, Okay, the side section of this is like this. Now they have given internal diameter, this diameter they have given, that is 200, and we want to find this external diameter. So for a tube or for this hollow cross section, what is the area formula? Area formula will be pi by 4 capital D square minus small d square. Capital D is nothing but external diameter, small d is nothing but internal diameter. Now we will write the given data. Now what they have given? Small d, that is internal diameter 200 mm, and external diameter they are asking us to find, and stress, P they have given, load, applied load 1.5 to 10 raised to 6 Newton, and stress they have given, that is sigma is equals to 100 Newton per mm square. So how to understand when they don't mention the stress or load, how to understand this is P and this is sigma, that is by unit. If it is N, then we can say it is load. If it is Newton per mm square, then we can say it is stress. Now to find this, the same way like a last problem, we have to take the stress formula, that is P by A. Now here what things we have? We have stress, we have P, we don't have area. So what is area formula? Here I have shown P by pi by 4 capital D square minus small d square. Now the whole term we will shift to the another side like this. Capital D square minus small d square is equals to P by pi by 4 sigma. Now what we will do? We will substitute the value of P and stress. First, P is 1.5 into 10 raised to 6 divided by pi by 4 into what is stress? Stress is 100. So value of this after solving is 19098.59. This is nothing but d square, capital D square minus small d square. Now what we will do? We don't know the capital diameter, external diameter, capital T. So what we will do? We know the small d, so we will transfer that term to this side. So the sign of at this side is minus. So when it is shifting to the another side, it will become plus. So capital D square is equals to 19098.59 plus small d square. What is the value of that? That is 200 square. So solving this, we will get d square is equals to 59098.59. So we want to find external diameter, that is capital D, and here it is d square. So we have to put square root to this value like this. So D become 3.10. So this is D. Now to cross check is it correct or no, how to verify with your answer, that is here. What is the internal diameter? That is 200 mm. And external diameter, it is 243.10 mm. So external diameter is always greater than the internal diameter. Like this, you can cross verify your answer. Thank you.